Hi, we are PK Squared, team number 33, and my name is Callie Lacey.
Hi, my name is Kaoxin.
I'm Patrick Schwartz.
I'm Patrick Betts, and we are the Car Head Tracking Project.
So have you ever felt like when you're in the car and you can't adjust your mirrors, or you're changing out drivers and you forget to adjust the mirrors? It has a lot of risks involved with that. Our project has been to develop a mirror system that will move as it recognizes your facial features. It recognizes where your face is, it will take the measurements, and it'll adjust the mirrors. It'll send it to the mirror, and that system is all powered by a 12-volt battery.
So for the first requirement of our system, it needs to track the head of the driver when the button is pressed. And then for the second requirement is that there will be a camera with IR sensors that calculates the depth between the driver and the camera.
Okay. And then once the camera determines the depth and the position of the person's eyes, an algorithm will determine the angle that the mirror needs to be at in order for the target behind the driver to be seen properly. And then the system must also have motors that are able to track the current position that can talk to the microcontroller that way.
The next requirement is that the whole system will be powered by a 12-volt battery, which simulates a car battery and an alternator. We use just a 12-volt lead-acid battery. And the next requirement is that the servos will move the motors to a location calculated by the algorithm.
Okay, and we'll move on to the demo now. Thank you.
Alrighty, so here's the demonstration for our senior design project for the car mirror tracking. So Coxon is going to come over here and he's going to take a seat in our driver's seat. That cardboard box there is our makeshift dash. The little black bar above the steering wheel is the camera that has infrared sensor or infrared capability to be able to determine the depth of the person's eyes. And so he's going to go ahead and start the car now by just flipping a switch, which connects our 12-volt battery system to the turn everything on to the power supply subsystem that gives 5.1 volts to the Raspberry Pi and 3.3 volts to our microcontroller that actually drives the motor. So it takes a little second for the car to actually finish turning on and booting up the Raspberry Pi just from limitations of the Pi itself. But then once it's ready, there is a button over on the side of the dash that he is going to press, and that will go ahead and start the system to be able to scan his face to determine the location and tell the microcontroller where the position needs to be. So it's currently checking for the location of his face, and then it sends that to the microcontroller. Now the mirror starts moving there. You can kind of see it moving, and we'll switch to the camera that Coxon has right now to show that he has approximately at eye level, to show that the mirror actually was able to find this target here. That pink stripe on the rod is where we are trying to view in the mirror, and so all the subsystems work together in order to provide a product that is able to locate that system by first scanning the face, sending that information to the microcontroller. The microcontroller has an algorithm in it that determines the proper angle that the mirror needs to be at. Then it also is able to read in the potentiometer values that tell it what position the mirror is in, so that we know where the mirror currently is and where it's going. And then after that, it adjusts it accordingly to be able to do it. And now to demonstrate that the mirror program works for all sorts of different people, we're going to have Patrick go ahead and sit down, because he's a different height than Coxon is, so we'll get it at a different level. So he's going to go ahead and do the same thing. He's going to go ahead and start the car up. And then he's going to go ahead and wait a little bit for the thing to start up and power the Raspberry Pi. For prototyping, it takes a little while. If we were actually making a full-on design of this, we could figure out how to get it to boot up faster, but for prototyping, this is good. And then now it's ready, so he's going to go ahead and press the button to have it check for his face. So now it's scanning his face, and we'll actually put up a picture in the corner of this screen here to show what the camera actually sees, just so that you can kind of see how it figures out where the face is. And then now it has finished calculating the screen and moves the mirror to where it needs to be, and Patrick can go ahead and show that it puts it in the right spot for the thing by moving the phone up to where his eye level is. And that is our demonstration.